So consider the transformation on how we can take regular binary registers and get regular m-valued registers out of them. And now we want to see the following. Let's say we replace the binary regular registers in these transformations with binary atomic registers. If we do this, will this transformation give us back atomic m-valued registers? To answer this question, we have to do the following. So if indeed it can lead this new transformation to atomic m-valued registers, we have to prove it, write down a proof. But if this is not the case, then a counterexample would suffice. So in this case, the transformation would not work. It would not give us back atomic m-valued registers. So we're going to present a counterexample. So consider this array of binary atomic registers, and then consider we have two processes, P1 and P2. And now we want to create an execution where atomicity is violated. So let's consider the following example. So let's say process P1 issues a write and writes 2, and later on issues another write and writes 5. At the same time, process P2 performs a read that is concurrent with both writes of process P1 and gets back 5, while then it performs another read that returns back 2. Now, as you can see in this execution, atomicity is violated. Why? Because the write 5 here has to be linearized before this read, but then this read comes after the first read of process P2, so this read should also read 5 and not 2. So can we have such an execution? If we change the binary regular registers to binary atomic registers. Indeed, we can have such an execution. So consider this read here. And let's say this read starts, it reads 0 in position 0, then it reads 0 in position 1, then it reads 0 in position 2. So at this point, after process P2 has read 0 in position 2 of this reg array, process P1 comes and writes 1 here, let's say at some point here. And let's say then process P2 continues, it reads 0, and then it reads 0 again, and then it pauses. And now consider that this time process P1 performs the second write, where it writes 5, and at some point here performs this write. So this write kind of that is here. So it also writes in this array. It writes 1 here in this array. Now when process P2 continues, it will come here and it will see there is 1. Since there is 1 here, this will return 5. And now process P2 performs another read operation, and this read operation starts reading, so it reads 0 here first, then it reads another 0, and then it reads 1. So it reads back 2, it returns 2. And this is possible because this read here runs in parallel with this write that writes 5. So while 5 goes backwards, in order to write 0 to all the possible locations, it could have been a bit slower, so 1 could still have been here for this read operation to return 2.